Hello and welcome. My name is Matúš König, and I'm currently working at Mews as a front-end developer, and I'll be trying to tell you a little bit more about performance optimization in React. So why do even bother with some stuff as a performance optimization? It's actually a great thing for the user experience and the user satisfaction. Nobody wants to use a laggy app. In extreme cases, nobody wants to use an app when you click the button, any action will actually take 30 seconds or so. This also means that there is some business perspective in your app. It's either user engagement or disengagement. So it means that you want to attract the user to spend the more time in your app, or spend no time in your app. And basically, any performance bottleneck is disrupting your business. Also, usually in any company building some specific products, there are some design system teams which are designing some components, and they are spending a lot of time to have some smooth and seamless animations, and you're just disturbing it. No. That's not how we do the business. And also, the last thing I want to mention is power efficiency. This is especially crucial for the mobile devices, as nobody wants to use an app which will burn through the battery in 1 hour. So let's get started. We'll start with a little bit of a theory. We'll define something we can call algorithmic complexity and an O notation. So OG marks a class of functions f for which the function g is the upper bound of the function f. So what we can imagine, and why is it useful? So this is one of the terms from the computer science, and it's helpful because we take the function g for some big input n, and also it's invariant for the multiplication constant. So just shorten it up, it's really helpful to measure time and space complexity, and we use it to approximate the number of operations of an algorithm. Approximate means the orders of magnitude and so on. We'll have a short example. We have an array. It has some elements. It's just a number. And we want to find an element which is in array only once. Easy. So we'll have some function which gets a value on an input, and it will return a number of occurrences in an array. Easy. However, when you want to find one element, in the worst case, it will take n to the power of 2 time. No, it's bad. You can do it in linear time. This difference is especially visible when you take a bigger input, because it will just freeze your app. And it's just a simple example. So the simplest thing we can do is actually to measure a raw performance of your functions. It's pretty easy. You just open the Chrome DevTools, go to the Performance tab, you prepare your screens, hit record, do some stuff, ideally on some big input, stop the recording, and you evaluate. In ideal scenario, you will see something like a nested calculation there, and it will be the function which needs to be fixed. Easy peasy. Regarding the other functions of the Performance tab, you can see like the function time, the total memory used, number of nodes, of React events like amounting of updating the states, a lot of useful information. But regarding the performance optimization, this is the most important thing, because you can see that there is some function which takes a lot of time to execute, even if it shouldn't, and you can fix it. Also, what it has is this beautiful summary view, which is great for measuring E2E performance of some, let's say, a happy tour of a customer. That way, you can define like a number of steps you want to execute. You can measure the time, and what is interesting, you can measure like the number spent in scripting, in rendering, in painting, or in different parts of the life cycle itself. Okay. Any questions so far? We shall continue. If the performance step fails, we can have something, I would say, lazy components. Don't confuse it with lazy loading if you are familiar with the concept. It's just the components which take a great amount of time to render without any visible causes. Usually, it's caused by some stuff like repeated calculations, which could be cached, or some faulty selectors, or just heavy rendering of some heavy page. It has a lot of reasons. Basically, you just need to do a whole investigation. But how you can find it? You can download React DevTools, and there is a really beautiful thing called React DevTools Profiler. Again, you hit the record, do your stuff, close the recording, and basically what you see is the teardown of each React commit with all the information you need, whether it was firstly mounted, whether it was updated. It will tell you the updated props, a lot of useful information. But the most important thing is it will tell you how long each of the components was working or mounting working. So in this specific example, we can say that the slow component was mounting for 1.4 seconds, which is just too much. We can just go to what the nasty calculation does. Let's say it was not visible in the previous performance step. It's just, it will add 100 million numbers to an array and drop it. So it's pretty useless. So we just render just some diff. But it's visible there, and from that point you can do your own investigation on what is wrong and why it is taking so much time to render. Another really useful thing is React Profiler component. We can say it here in the example that it is a component. You pass there some ID and some onRender function, which takes an ID, of course, and a phase, which is a mount or update, and it has a durations. Why it is useful? I haven't found a way to use the React profiler to work with some specific queries. For example, you have a component which has 1,000 little one icons, for example. This is a pretty specific example. And you know that something's wrong, but the profiler won't tell you that, for example, the icons alone in aggregated time will take 1 second to mount. This is what you can use the profiler for and calculate the aggregate statistics for you. Also, if you want, you can connect it to your some logging tools and eventually send the performance stats to your logging provider and eventually analyze it later, whether the performance of your app is degrading or it's being stable or whatever. So you can create logs. One important thing to mention is that actually the profiling is only enabled in development builds and profiler builds. They are disabled in production builds. So if you want to enable in production, you have to switch to the profiler build. Okay, so any questions so far? Okay, we will jump to the last.
One question, please.
Yes.
So if I understand well, that I can put the profile component anywhere
Yes.
I would like.
Yes. and it's measuring the performance of the children.
Okay. So, and do you have some tips for this component, or?
Yes, actually, it's the icons. That's what I've discovered, that in our application, for example, we have icons wrapped in style components, and for some reason we felt some regression in the performance. And I was investigating it, and I found out that using styled components for really small components, however, which are heavily spread across the app, which are icons. We can have thousands of icons active at the same time. It's not a big deal. And it has a really heavy performance impact, for example. Any further questions? Yes?
Is there a way to wrap all the components in the profiler?
You can. It's not a problem. However, it will just measure the children, the first level children. Oh, yes.
Wait, what?
I meant just the component that's wrapped in the... Yes, immediate children. Yes.
Right, okay, cool.
Any other question?
Can I? To follow up on the icons, like how did you actually find out? Because if you have like many icons all around the application, I guess if you measure the performance of one single icon, it's okay. But if you measure kind of the whole total of it, this is where the problem is. So how did you actually find out? Because I guess the profiler doesn't like sum up all of this together, but it just does one of those.
That's the really interesting question, and it's the great one. The thing is, you never have really a complete information at any time at the silver plate, so you need to investigate. In our case, for example, the screen is divided into right-hand side and left-hand side. Left-hand side is forms. The right-hand side, you just do basically a selection of the data, let's say. And there are a lot of icons there. And you just start measuring that. Yes, the right-hand side is slow. And you just focus one level over. And then you just disable some selectors, for example. And then you come to the conclusion that, yes, those icons are super slow. And eventually you just do it that you just wrap it in the profiler and set up some aggregate statistics. And it will just match up with what you will find in the profiler that, for example, it's taking 50% of the whole of the component render time.
That makes sense. Thanks.
So I will jump to the last and eventually the most difficult performance pitfall you can find. And it's actually a memory leaks. So a last piece of theory, JavaScript has a garbage collector. So eventually you have two main memory management models. You have a managed memory and unmanaged memory. Unmanaged memory is a C or C++. You just manage the memory yourself. And in managed languages, such as JavaScript or C#, for example, there is a garbage collector. So basically, you just allocate the memory by using some keyword, and you forget about it. The garbage collector will do its magic. How it works, let's say it has, in simplicity, it's a mark and sweep algorithm. So basically, you have some roots, you have some reachable objects, you mark them, you delete the rest. That's it. So pretty simple. So you need to think about reachable objects. However, you still can create a memory leak by accidentally keeping a reference to some live objects in some root. Can happen. It usually doesn't happen when you are building something simple. And it usually doesn't happen until you start messing with some global objects or eventually do some pretty exotic stuff with some eventually external resources. Why is memory leak such a big performance pitfall? We have some allocated memory. We cannot free it. However, the runtime is asking for more memory. So it runs garbage collector. It cannot free any. However, you go all through the live objects, you free none of the memory, you're at the beginning, and still you're asking for the memory. So all the time you are just garbage collecting memory, which just you cannot free. And voila, you have performance bottleneck. How can you identify it? The first thing is to understand when you have a memory leak. It's actually the easiest part. You go to the Chrome DevTools. Again, you go to the memory tab. And you are at the start of your application. You just mess around, do some eventually heavy stuff. You go to the same place you started. You hit clean button, that little garbage can. This will force the garbage collection. And you should eventually end up the same amount of memory you have started with. If you don't, you have a memory leak. And then it's up to you to decide whether it's a big one or a small one. What you can do about it? That's the funny part. You need to do a pretty heavy investigation. You can do a heap snapshot, that. You can do allocation instrumentation on timeline, which basically records what objects have been allocated, and then you just run the garbage collection, close the recording, investigate, blah. In any case, it's just a lot of time to spend, and it's pretty heavy investigation. One thing I want to note specifically is detached nodes. This can happen that if some DOM node is detached from the document. So it has no root node which is connected to the main DOM node. It has no real rendered parent. These nodes are usually some, for example, stale pages, and it can happen that you can't free them. However, there is a pretty cool extension in the Edge, actually. So that's the only reason I found Edge browser useful. And it has a detached node step, which will allow you to go through all of the detached nodes and eventually find out why it's leaking. Also, why usually memory leaks happen? It's in 3 times I've had a pleasure to deal with them. It was 3 times with dealing with some external resources and some random magic. Let's say we have some external resource. It has a set of listeners, which is just a function accepting a new value, which will actually be somehow processed. We have some notify value function, which will call the notify change function of each of the listeners with a new value. And we have a subscribe function. It's easy. In the first step, we add the update function to the listeners. And we return unsubscribe function, which will delete the listener from the sets of listeners. Easy. In the next 3 lines, I'm just setting some heartbeat, so we will get some constant updates. We have some incorrect implementation. We have some state. We have some use effect. However, we are ignoring unsubscribe. What does it do if we have, for example, 1,000 components which we are mounting and unmounting repeatedly? Well, the listener set will just get bigger and bigger and bigger, and you will never clean it out. This means you have some memory leaking, and you might eventually run out of memory. What is also more important, since we are passing there a set external value, which is some function keeping a React instance in its closure, you are actually running a pretty decent problem if you have multiple React instances running in your app at the same time. Because if you are unmounting the React instances, you are not actually cleaning them out of the listener set because they are kept in the closure. So how you can do it properly while you are subscribing to some external resource. Don't forget to unmount and clean your subscribe. Any questions? Okay, so we are coming slowly to an end. So I have some just small tips which are not worth some specific slide. There is a caching. It is pretty helpful. It can save you a lot of computing time if you do it properly. However, doing improper caching usually harms more than doing no caching at all. So it's pretty important to do it right. You can use either some state-of-the-art libraries, or basically it's worth another lecture. But okay, I'll just sort it up. Be careful about the equality, because in many cases you want to have some caching on non-primitive values. Pretty common example is you pass there an array of IDs, which is a string array. However, it's not primitive value. So all you can do is just a reference equality, which sucks, because at that time you cannot track the value equality, and this is actually a pretty common pitfall at create selector as reselect, and it's creating a lot of performance bottlenecks. And we have a couple of things which are connected to the DOM itself. Be careful about connecting DOM properties and React. It usually adds a lot of bottleneck if you are listening, for example, to the element height or width, and then retroactively updating the state. It's usually pretty expensive and causes a lot of re-renders. This also includes touching and reading and writing DOM properties and node properties itself. Why it is bad to just read them randomly? You need to have some order. You need to read them all at first, and then you need to do a batched write, because the read and write operations are actually synchronous, and basically writing a value invalidates all the caches, and the whole DOM needs to redraw itself and recalculate the layout. Another pretty important thing is to prepare your data beforehand. If you know that you will have some big component, for example, tables, do not calculate the data in each cell. Calculate the data by rows, and by that you can get a much better performance, mostly considering some computation-heavy tables. The last thing I want to mention is that when every other aspect of this fails, maybe you have just too many components. What you can do about it? If it is a list, you can consider virtualization of a list. That is cool, and it works. However, you can also talk to a designer if you have some pretty complicated screen, and maybe you just want to hide some more content under some buttons or dialogues. So basically, you will free the JavaScript engine from any more rendering. So, take-home message: DevTools are your friend, not your enemy, and it can save you many times, as it can provide you a lot of useful information which you can use and eventually consume to fix all your performance problems. Also, write efficient code from the beginning. Think about the complexity of the code. Think about what the code does, because there is no silver bullet in performance optimization, and every time you do it, you need to spend a lot of time to investigate even where the problem lies, not how to fix it. So, any further questions? Yes?
Maybe I'll ask a question. I understand that you can have like memory leaks
yes.
by not unsubscribing from like an observable.
Yes.
But you're also talking about detached DOM elements.
Yes.
How can you get memory leaks with that?
That's actually a pretty great question. We have some legacy code in the system which will actually render a template in the backend, which contains some JavaScript code which will mount a React element inside that code, basically. So basically, what you have is some, let's say, dangerously set HTML element which will accept HTML, render the HTML, and the HTML itself will render another React instance with some components. It's not the greatest design, but it's a legacy code. We want to get rid of it. We are working on it. I'm sorry. But yes, what can happen is that you might actually unmount the React instance that works internally by just setting some null to the element. However, you keep some reference in some random node in that set HTML element. It's pretty specific example. I mean, it took me 3 days to figure it out what's wrong with it. So that's why I wanted to mention that it can have a big performance impact.
All right, thanks.
Mm-hmm. Yes.
You said that you had some problems with too many icons styled in style components.
Yes.
So do you know what was causing the speed problem?
No. No. I think it's the library itself. At least what the investigation suggested. But I haven't managed to fix it nor improve it.
And how many icons are you talking about?
In that specific example, in that specific component on the right-hand side, we are talking about 750 icons times 3. So many icons, yes. And one icon is 1 millisecond each. So you can, it's like, let's say 2 seconds just on rendering icons, which is just too much.
React icons style with style icons, or it was just some custom?
It was, I think it's just an icon. And it's actually a wrapper around some SVG, the SVG icon, and then it's style component icon wrapper, basically, defining the style.